CBSE Class 10 Math, chapter-wise revision. We are in chapter 10, Circles. Two key concepts covered in this chapter. Both of these are theorems. The first one is a theorem about angle between a tangent and the radius where the tangent comes in contact with the circle. The second one is a theorem about the lengths of a tangent, lengths of two tangents drawn from an external point to a circle. Quite a lot of questions that are tested from this topic time and again have been proofs. So proofs are an integral part of the questions that are going to appear from this topic. We'll run through both these theorems, we'll prove some of them, and we'll also run through a bunch of questions based on how this concept, these two theorems have been tested in the past board papers and sample question papers. Let's get started with the first theorem. First theorem is the tangent at any point of a circle is perpendicular to the radius through the point of contact. In this diagram, look at it. XY is the tangent. It's in contact with the circle at point P. The radius at point P, which is OP, will be perpendicular to the tangent through the point of contact. Essentially, OP and XY are at right angles. They are perpendicular to each other. That's theorem number 1. The second theorem, the lengths of tangents drawn from an external point to a circle are equal in length. External point is P, circle center is O. We have drawn two tangents, PQ and PR. Both these tangents will be equal is the second theorem. PQ will be equal to PR. Let's get started. Let's start proving this as the first step. Question 1. Prove that the lengths of the tangents drawn from an external point to a circle are equal. We'll be proving it using congruent triangle basis. Right? Let's get started. I'm going to draw this diagram. O is the center of the circle. P is an external point from which I have drawn two tangents, PQ and PR. PQ meets the circle at Q and PR meets the circle at R. So these are the points where it meets. What do we have to prove? We need to prove that the lengths of both these tangents are equal. That is, PQ is equal to PR. Let's construct three lines. I'm going to join OR, OQ, both of which are radii. And I'm going to join OP. So we've drawn all of these things. By the first theorem that we had, let's do the proof here and recap it. By the first theorem we had, at the point where the tangent meets the circle, the radius drawn and the tangent will be at right angles. So we know that angle OQP is 90 degrees. Similarly, angle ORP will also be equal to 90 degrees. So OQP is 90, ORP is 90. So triangle OQP and triangle ORP, we know that both these triangles are right triangles. So establish that. The side opposite to the right angle is going to be the hypotenuse. So right angle is this angle at vertex Q, which means the side opposite to it is OP in triangle OQP. In triangle ORP, OP is again the side opposite to 90 degrees. So the hypotenuse to both these triangles is the common side, which is equal to OP. So both these triangles are right angle triangles. Both have the same measure of hypotenuse. OQ is one of the perpendicular sides of this right triangle, which is the radius to the circle. OR is one of the perpendicular sides of ORP, and that also is the radius. So we have one perpendicular side which is equal, which is OQ is equal to OR. So right angle triangle, hypotenuse same, one side equal in both the triangles. By RHS, we can say that these two triangles are congruent triangles. So we established OQP and ORP are congruent. By corresponding parts of congruent triangle, in congruent triangles, corresponding parts will be equal. What are the corresponding parts? PQ and PR are the corresponding sides. So PQ and PR should be equal. So we have proved it using CPCT, right? So this is what we needed to prove. We have proved that. Quickly summarize it in a printed form. PQ is a tangent to the circle. By the theorem, we can establish that OQ and PQ are perpendicular to each other. Therefore, triangle OQP is going to be a right triangle. Go through the same process. We know that OR and PR will be perpendicular to each other. The angle ORP is a 90 degree right angle, which means that triangle ORP is also a right triangle. These two triangles are right triangles. That's been established. Common hypotenuse OP. And then one of the perpendicular sides OQ and OR happen to be the radii of the circle. Therefore, by RHS congruency, we know that these two triangles are congruent. These two triangles are congruent. Corresponding parts of congruent triangles, PQ should be equal to PR. So from an external point, draw two tangents. Both these tangents will be equal. So I proved this. Let's move on to the second one. This is also a proof. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. Lovely question. Set about proving it. The circle whose center is O, the diameter is AB. Ends of the diameter are A and B. We are drawing two tangents PQ and RS through points A and B. What we need to prove is that these two tangents PQ and RS are parallel. That is, PQ is parallel to RS. We need exactly two things to prove this. The first one is this theorem. Tangent at any point of the circle is perpendicular to the radius through the point of contact. Tangent is PQ. It's at contact with the circle at A. the radius drawn at A, which is OA, will be perpendicular to the tangent. Essentially, angle OAP equals 90 degrees. Using the same concept, angle OBS is also equal to 90 degrees. So we established these two that has been drawn here. The second thing that we're going to draw is basically this entire diagram as taken from the previous slide. I'm going to add this line PS. PS is a transversal drawn in between two lines PQ and RS. Now, these two angles, I'll call it as angle theta and angle alpha. I'll call these two angles are theta and alpha. QPS is theta, angle PSR is alpha. These two angles are called interior alternate angles. They're interior because they're in between these two lines PQ and RS. They're alternate because they're on either side of this transversal. PS is nothing but a transversal. If this theta is equal to alpha, then it will happen only when PQ is parallel to RS. Now this is a transversal. The transversal could have been this way. The transversal could be this way. AB is nothing but a transversal to these two lines PQ and RS. Angle OAP and angle OBS are nothing but interior alternate angles drawn by this transversal, which is the diameter of the circle. We know that these two angles are equal. Both of these are right angles. So we established that the interior alternate angles are equal. Two lines are said to be parallel if their interior alternate angles are equal. In this case, the interior alternate angles are equal. Therefore, PQ is parallel to RS. Move on to the third question. In the given figure, this is an objective type question. So obviously, it's a 1 mark question, a very simple one. The given figure, if TP and TQ are tangents to a circle, the center of the circle is O, such that angle POQ is given as 130 degrees. We need to find out the measure of angle PTQ. We need to find out what is the measure of this angle. We know the theorem that the place where the tangent meets the circle, the radius drawn at that point is going to be at right angles to the tangent. So which means that OPT is 90 degrees because PT is a tangent. Similarly, QT is a tangent. This angle is also going to be equal to 90 degrees. Now look at it. In OPTQ, what we have is a quadrilateral. Sum of interior angles of a quadrilateral is equal to 360 degrees. Very simply put, we know sum of these two angles, 90 plus 90, this is equal to angle P plus angle Q is equal to 180 degrees. These two have added up to a 180, which means that angle POQ and PTQ should also add up to a 180. If this is 130, this angle is equal to 50 degrees. That's all it's going to take. But I'm going to do it in a little more in depth. You don't need to do anything at all because in an objective type question, no one looks at your steps. They have to just see that your mark B and that's what the answer is. But let's take it a little step by step in case what I explained right now is not very clear. Right? Let's run through this process. OP and OQ are radii to the circle. TP and TQ are tangents to the circle, meeting the circle at P and Q. By the theorem that at the point where the tangent meets the circle, the tangent and the radii will be at 90 degrees. These two angles will end up becoming 90 degrees. So we know that these two angles are 90 degrees. In a quadrilateral, sum of the interior angles is equal to 360 degrees. What are the four angles? These are the four angles. POQ is one angle, TPO is the second angle, TQO is the third angle, and PTQ is the fourth angle. We know that POQ is equal to 130, TPO is 90 degrees, TQO is also 90 degrees. This is what we are trying to find out. These add up to 180 plus 130, which is equal to 310 plus angle PTQ is equal to 360 degrees. Take this 310 to the right hand side, get the value of PTQ to be equal to 50 degrees, right? So I just basically marked it and did it, saying that these two add up to a 180. These two should add up to another 180. This is 130, so this is 50. That's possibly a quicker way of getting to this without writing all of these steps. Choice B is the answer to this question. So on to the fourth question, talking about concentric circles. What are concentric circles? Concentric circles are two circles which have the same center with different radii, right? Something like a bullseye is a concentric circle. Two concentric circles of radii 13 centimeters and 5 centimeters. The external one is going to have 13 centimeters as the radii. The internal one is going to have a radius of 5 centimeters. Find the length of the chord of the larger circle which touches the smaller circle. We've been asked to find out a chord of the larger circle and that chord should touch the inner circle, which means that that chord is going to be a tangent to the inner circle. This is the diagram we are talking about. Inner circle, AD is the radius to the outer circle, radius is AE. AF can also be radius. Any point here is going to be a radius. So AF will also measure the same 13. This is going to be 13 centimeters, radius of the outer circle. EF is the chord we are talking about. EF is a chord to the outer circle. It touches the inner circle at D, which means that we know that ADE and ADF are going to be 90 degrees for the simple reason that at the point where the tangent touches the circle, the tangent and the radius will be at right angles to each other. Now look at it. We have the measure of the hypotenuse of, I'm going to look at right triangle. I'm just going to pick right triangle ADE. What do we have to find out? We need to find out the measure of this. In right triangle ADE, I know that AE square, which is the hypotenuse, is equal to AD square plus ED square. I need EF. Let me find out ED as step number 1. AE square is 13 square. AD square is equal to 5 square. This plus ED square completes the Pythagoras theorem. So ED square therefore will be equal to, taking this to the right, left hand side or right hand side, 169, which is 13 square, minus 25, which is equal to 144. ED square is equal to 144. ED, this portion measures 12 centimeters. So found out ED. Quickly summarize it in a printed form. In this right triangle ADE, we are applying Pythagoras theorem with the hypotenuse being AE and one of the perpendicular sides being 5. Therefore, we get the value of ED to be equal to 12. Now look at it. Here what do we have? In triangles ADE and ADF, both of these are right triangles. Both of these are right triangles. The hypotenuse is AE and AF, both of which are radiate to the outer circle. So they have the same hypotenuse. They have a common perpendicular side in AD. AD is common to both. So by RHS, we know that these two triangles are congruent triangles. They're congruent triangles. By CPCT, ED should be equal to DF. ED is equal to DF. DF is also equal to 12. This is a 12. This is also equal to 12. The chord's measure is EF, which is ED plus DF, which is equal to 24 centimeters. So we did first establish that this is a right triangle. Using Pythagoras theorem, found out ED. Second, we established that ADE and ADF are congruent triangles by RHS rule. And then using CPCT, deduce that DF is the same as ED. So EF, which is the sum of these two parts, is equal to 24 centimeters. Move to the next question. The angle between two tangents drawn from an external point P to a circle of radius R and center O is 120 degrees. Find the length of OP. Do we have any numbers given here? No. So essentially, we'll have to establish a relationship between what OP is in terms of the radius. That's what this question is all about. Quickly draw the diagram. From an external point P, we have drawn two tangents PA and PB. Center of the circle is O. Meets the circle at A and B. The angle between these two tangents is given to be equal to 120 degrees. Radius of the circle is OA, OB. We know that at the point where the tangent meets the circle, the angle is going to be 90 degrees. So OAP is 90 degrees. OBP is also equal to 90 degrees. Both of these are right angle. Radius is common. Common hypotenuse OP. So by RHS, we know that triangles OAP and OBP are congruent. Triangle OAP and triangle OBP are congruent triangles. They're congruent triangles. Obviously, corresponding parts of congruent triangles will be equal. I'm going to look at angle in this case. I'm going to look at angle OPA or APO, whichever one you can look at it, is equal to angle BPO, right? Angle APO, this angle is the same as angle BPO. Let's say both these angles are equal to theta. So this is equal to theta, this is equal to a theta. Theta plus theta, which is 2 theta, is equal to 120 degrees, which means theta is equal to 60 degrees. So this angle alone is equal to 60 degrees. Quickly summarize this bit in a printed form. We've established that these two triangles are congruent triangles by RHS. Corresponding parts of congruent triangles will be equal. So this angle is equal to 60 degrees. I'm going to delve a little bit into trigonometry. Now we have a right triangle OAP. In right triangle OAP, to angle 60 degrees, OA is the opposite side. We need to find out the measure of OP in terms of this. OP is the hypotenuse. Opposite side and hypotenuse, the trigonometric ratio that we are going to be talking about is sin theta. So in triangle OAP, sine of angle 60 degrees is equal to OA divided by OP. Sin 60 is equal to root 3 divided by 2. OA is equal to R. OP is what we are trying to establish in terms of R. Cross multiply, we'll get OP is equal to 2 by root 3 times R. Quickly summarize it in a printed form. Looking at triangle PAO, which is right triangle, looking at this angle is equal to 60 degree, angle APO. Sine of this angle is equal to opposite side OA divided by hypotenuse, which is OP. Sine 60 is equal to root 3 by 2, which is equal to R by OP. So OP is equal to 2 by root 3 R. Small. Sixth question. AB is a chord of, it's a very lovely question, good question. It's a solved example in the NCERT. You just change the numbers. So we'll quickly run through it. The solution method that we've adopted is a little different from the way it is given in NCERT. The NCERT book expects you to know a lot of things. This starts from first principles, the solution that we have for this question. AB is a chord of length 6 centimeters of a circle of radius 5 centimeters. We have a chord of length 6, radius of the circle is 5. The tangents at A and B, the chord will meet the circle at 2 points on the circumference. We're drawing tangents from A and B, right? The tangents at A and B intersect at point C. Find the length of CA. Let's see what this diagram means, right? AB is a chord we are talking about. Tangents from A and tangents from B meet at an external point C. What we need to find out is the measure of the CA. Let's put this as a question mark, which we need to find out. Let's call it as x centimeters for the time being. Center of the circle is O, so radius of the circle is equal to 5 centimeters, right? So data given to us, AB, the chord is equal to 6, OA is equal to 5. Lengths of tangents drawn from an external point will be equal, so CA is going to be equal to CB. If this is x, this will also be equal to x. At the point where the tangent meets the circle, the tangent and the radius will be at right angles. So angle OAC, this is equal to 90 degrees. So established all of this till this point. Let's move on to this diagram. I'm drawing a perpendicular CD to AB. CD is perpendicular to AB. So this angle is equal to 90 degrees. Obviously, this will also be equal to 90 degrees. No doubt at all. Now, look at both these triangles. Consider triangle ADC and triangle BDC. Both of these triangles are right angle triangles. Established. We know that from an external point, the two tangents drawn will be equal. AC is hypotenuse to triangle ADC. BC is hypotenuse to triangle BDC, which means both of these have the same hypotenuse. CD is a common perpendicular side to both of them. So one side is equal. By RHS, we can establish that these two triangles are congruent triangles. Triangle ADC and triangle BDC are congruent triangles. Now that we established these two triangles are congruent triangles, by CPCT, corresponding parts of congruent triangles will be equal. AD will be equal to BD. We know AB is equal to 6. If AD is equal to BD, then both of these will be equal to 3 centimeters. By CPCT, we have established that both these values are equal to 3 centimeters. So I found out one thing using the fact that these two triangles are congruent triangles. Let's move on to the next one. In this diagram, I'm joining OD. Now let's look at triangle ADO and triangle BDO. OB is radius, so that's also going to be 5 centimeters. Triangle ADO, one side is 5, one side is 3, and let's say OD, for sake of convenience, let's say it is equal to y centimeters. In triangle BDO, one side is 5, one side is 3, one side is y, which means that by triple S, we can say that these two triangles are congruent triangles. ADO and BDO are congruent triangles. If ADO and BDO are congruent triangles, then corresponding parts of congruent triangles being equal, angle ADO is equal to angle BDO. So if say each of these angles is equal to a theta, theta plus theta, this is equal to theta. Theta plus theta is angle in a straight line, which is equal to 180 degrees, which means theta is equal to 90 degrees. So we established that angle ADO is equal to BDO, which is equal to 90 degrees. And these two triangles are right triangles. These two triangles are right triangles. By Pythagoras Theorem, we'll be able to find out the value of OD. OD is equal to square root of the hypotenuse square, which is 5 square, minus one of the perpendicular side square, which is equal to 3 square. 5 square is a 25 minus 9, which is equal to root 16, which is equal to 4. So we have found out the measure of 4. Quickly find out the measure of 4 in the next slide, consolidate it, and then move on. What is our idea? We need to find out this x. So where are we right now? We have found out this 3, we have found out this 4. So we're applying Pythagoras Theorem on this right triangle ADO. We get the value of OD to be equal to 4 centimeters. Let's move on further and see how we get further. We'll say this measure is equal to an x. I'm looking at right triangle ADC. In right triangle ADC, apply Pythagoras Theorem. X square is equal to 3 square plus DC square. So x square is equal to 3 square is a 9, is equal to a 9 plus DC square. So keep this as equation number 1. We got this. Do we have one more right triangle? Yes, look at it. We have this angle to be a 90 degrees. So the next slide, I'm going to look at this right triangle. I'm going to look at right triangle. I'm going to shade it for our convenience. This is the right triangle we are talking about. We are talking about right triangle OAC. This is 90 degrees. So in this right triangle, the hypotenuse is OC, this entire length. We know OD is a 4. We know CD, let's keep it as CD. So we can write this OC. OC can be written as 4 plus DC. We'll write it as 4 plus DC. So in this place, we're going to replace this OC is as a 4 plus DC the whole square, which is equal to sum of the squares of the other two perpendicular sides, which is 5 square plus AC, we call it as x. So this is 5 square plus x square. Expand this, we'll get this as a 16 plus 8 DC plus DC square is equal to 25 plus x square. Go back to the last slide if you want. What did we say the value of x square was? X square is equal to DC square plus 9 is what we said. Let's replace that here. So 16 plus 8 DC plus DC square is equal to 25 plus 9 plus DC square. DC square gets cancelled with DC square. Take all these constant terms to one side. So we'll have 8 DC on the left hand side. 8 DC is equal to 25 plus 9, 34 minus 16, which is equal to 18, which means the measure of DC is equal to 18 divided by 8, which is equal to a 9 by 4. So found out DC right now. So what did we do? We expanded this as a 4 plus DC the whole square, which is 25 plus x square. So the 16 plus DC square plus 2AB is equal to 25 plus x square. DC square will get cancelled with DC. We haven't come to that yet, right? So we have, x square is equal to DC square plus 8 DC minus this 25 coming to the side. 16 minus 25 will leave us with a minus 9. I'm going to plug in this value of x square as a DC square plus 9 from the previous one. So DC square gets cancelled with DC square to find the value of DC to be equal to 9 by 4. DC is equal to 9 by 4. You know the measure of this is equal to 3. We need to find out the value of x. So x square is equal to 9 by 4 square in right triangle ADC plus 3 square. 9 square is 81 divided by 16 plus 19 is the value of x square. Take 16 as a common denominator. So it's going to be 81 plus 9 times 16 is a 144. This is 225 by 16. X square is 225 by 16. X is equal to square root of 225 divided by 16, which is 15 divided by 4. So basically plugging in x square is equal to 9 plus DC square. Found out the value of DC as a 9 by 4. Finding out the value of x to be equal to 15 by 4. So the length of the tangent which we have to find out is equal to 15 by 4. Beautiful question. We established everything ground up. We proved congruence of these two triangles ADC and BDC. We also proved congruence of triangles ADO and BDO. And established that both of these triangles are right congruent triangles and did it ground up. Run through this. It's a lovely way to consolidate all the different properties of triangles, congruence and circles in one go. Move on to the next question. So last question we'll be looking at. Prove that the parallelogram circumscribing a circle is a rhombus. A similar question has been tested saying that prove that a rectangle circumscribing a circle is a square in one of the sample question papers. We just tweaked it a little bit. Actually, I think this is an exercise question in the book. Right. So center of the circle is O. ABCD is a parallelogram which is circumscribing it, which means that the four sides of the parallelogram will be tangents to the circle. Let them touch the circle at points P, Q, R and S. What do we have to prove? We need to prove that ABCD is a rhombus. A rhombus is a parallelogram where all sides are equal. So essentially, let us say this is, if this measures A, this is also going to measure A, this is also going to measure A, this is also going to measure A. So AB equals BC equals CD equals DA. Key property of a parallelogram: opposite sides of a parallelogram are equal. That is given, which means that AB, whatever it is that measure, is going to be the same as CD. AB is equal to CD and AD will be the same as BC. So BC is equal to AD. This comes from the property of a parallelogram. We know this is definitely a parallelogram. Now look at it. From point A, AP and AS are two tangents drawn to the circle, which means from an external point, the two tangents drawn to a circle should measure the same. So AP will be equal to AS. Similarly, from B, we have drawn two tangents. BP will be equal to BQ, CQ will be equal to CR, and DS will be equal to DR. So that's what I've written here. It's very simple beyond this. We're going to add all these four equations, 2 to 5. LHS of these equations, if I add, I'm going to get AP plus BP, AP plus BP plus CR plus DR. This is the LHS added. This is equal to AS plus BQ plus CQ plus DS. AP plus BP is nothing but AB. CR plus DR is nothing but CD. I'm going to add these two right now. AS plus DS is nothing but AD. And lastly this BQ plus CQ, that is equal to BC. Because it's a parallelogram, we already know that AB is equal to CD. So AB plus CD can be written as AB plus AB. Because it's a parallelogram, AD is equal to BC. So we can replace this BC with another AD. So this is going to be AD plus AD. So 2AB is equal to 2AD, which means that AB is equal to AD. Now let's quickly do one thing. I'm going to say AB is equal to X, which means that AD is also equal to X. Is everyone okay with this? We know AB is equal to CD. If AB is X, this will definitely be an X. We know AD is equal to BC. If this is an X, this is also going to be an X. So we established that all of these four measure X, which means that ABCD is a rhombus. Summarize it in a printed form. We've added the LHS and RHS. AP plus BB clubbed, CR plus DR clubbed, AS and DS clubbed, and BQ and CQ clubbed. That leaves us with AB plus CD equals AD plus BC. AB is equal to CD. So we're replacing the CD with an AB. We know that AD is equal to BC, replacing the BC with an AD. So we established that AB is equal to AD. We have established AB is equal to AD. We know AB is a CD, which means that AB will be equal to CD will be equal to AD. We know AD is equal to BC. So all these four are going to be equal. Instead of writing it this way, you can also put the X and go about it in that fashion. That will make life that much easier to comprehend. So it's a parallelogram which is given. Parallelogram where all four sides have been found to be equal. If all four sides are equal, then the parallelogram becomes a rhombus. When all did we see questions from circles? 16, 17, 19 sample paper, 19 board paper, 20 sample paper. Quite a few questions. Look at it. In 16, for instance, we have 5 questions that came from circles. 17, 4 questions. Look at the sample paper with 3 questions for the basic and 2 questions for the standard version. So it's an important topic. Exactly 2 concepts. Run through these 7 questions. They basically cover the whole gamut of different kinds of questions that have appeared and could have got tested from this particular chapter. Before you leave, do 2 things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. It takes less than 5 minutes in all of 3 steps to get started. And do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.